This is KVS Naidu, Lecturer in Mathematics, Miriam College, Amalapuram. In this session, I would like to explain zero divisors of a ring. Zero divisors of a ring. Two non-zero elements. Two non-zero elements. Definition. Two non-zero elements A comma B of a ring are said to be zero divisors, are said to be zero divisors if AB is equal to 0, where 0 belongs to R, is the zero element, that implies two non-zero elements A comma B of a ring are said to be zero divisors if AB is equal to 0, where 0 belongs to R is the zero element. In particular, A is left zero divisor, B is right zero divisor. A is left zero divisor and B is right zero divisor. In other words, A not equal to 0 belongs to R is a zero divisor if there exists B not equal to 0. If there exists B not equal to 0 such that AB is equal to 0. This is the definition of zero divisor. That implies A not equal to 0 or B not equal to 0. That implies AB is equal to 0. Product AB is equal to 0. A not equal to 0, B not equal to 0. The product AB is equal to 0. Example: the ring Z6 plus dot has 0 divisors. Z6 means Z6 is equal to 0, 1, 2, 3, 4, 5. This is the addition modulo 6 and multiplication modulo 6. Addition modulo 6 and multiplication modulo 6. Already we learned group theory, addition modulo m and multiplication modulo p. This is definition of addition modulo m. A addition modulo m b is equal to r. R is the remainder. Adding a plus b and divides m is equal to remainder r. Multiplication modulo p is equal to b, is the r is the remainder. Multiply a and b and divides p, it is the r is the remainder. So Z6 2 comma 3 belongs to Z6. That implies this is the product. Product AB is equal to 0. A not equal to 0. 2 not equal to 0 and 3 not equal to 0. The product AB is equal to 0. 2 multiplication modulo 6, 3. That implies 2 into 3, 6. 6 divides 6. 6 divides 6. That implies 1 time, the remainder 0. That implies 0. 2 not equal to 0, 3 not equal to 0. 2 multiplication modulo 6, 3 is equal to 0. 6 divides 6. Another example in Z6. 4 into 3. 4 multiplication modulo 6, 3 is equal to 12. 4 into 3 is the 12. Divides 6, remainder 0. That implies 0. 4 not equal to 0 and 3 not equal to 0. The product 4 into 3 is equal to 0. So Z6 comma plus comma dot has 0 divisors. Next, another example in matrices. Another example of 0 divisors in matrices. 2 by 2 matrix, take A is equal to 2 by 2 matrix, B is equal to 0 0 1 0. A is equal to 1 0 0 0. B is equal to 0 0 1 0. That implies A not equal to 0 and B not equal to 0. This is the 2 by 2 matrix. The ring of M2 comma plus comma dot. The ring M2 plus comma dot. This is the elements in matrix has integers. Elements in matrix is integers. So A not equal to 0 and B not equal to 0. AB is equal to 0. Product AB, that implies 1 into 0 0, 0 into 1 0, 1 into 0 plus 0, 0 into 0 plus 0, 0 into 0 0, 0 into 1 0, that is equal to 0 plus 0, 0 into 1 0. It implies 0 0 0 0. This is 0 matrix. 0 is the 0 matrix, 2 by 2 matrix. So AB is equal to 0. 0 is the 0 matrix. A not equal to 0 and B not equal to 0. So AB is equal to 0. So M2 plus comma dot has no 0 divisors. A not equal to 0 and B not equal to 0. AB is equal to 0. So M2 has no 0. M2 has 0 divisors. M2 plus comma dot has 0 divisors. Next, no 0 divisors. Definition of no 0 divisors. No 0 divisors. No 0 divisors. A ring R has no 0 divisors. R has no 0 divisors if and only if A comma B belongs to R and AB is equal to 0. That implies A not equal to 0 or A is equal to 0 or B is equal to 0. AB is equal to 0. The product AB is equal to 0. Any element A is equal to 0 or B is equal to 0. On other words, A not equal to 0 comma B not equal to 0. AB not equal to 0. A not equal to 0. B not equal to 0. That implies AB is not equal to 0. For all A comma B belongs to R. This is the no 0 divisors. Example, set of integers z. Set of integers z minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Take two elements 2 comma 3 belongs to z. 2 not equal to 0 and 3 not equal to 0. 2 not equal to 0 and 3 not equal to, that product 2 into 3 is equal to 6 is not equal to 0. So A not equal to 0, B not equal to, that implies AB not equal to 0. The ring Z has the ring Z has the ring Z has ring of integers Z has no 0 divisors. The ring Z has no 0 divisors. The ring of integers Z has no 0 divisors. This is the definition of no 0 divisors. Next definition, cancellation loss. In a ring, cancellation loss in a ring. Cancellation loss in a ring. In a ring or for A comma B comma C belongs to R if A not equal to 0. First one, left cancellation law. AB is equal to AC, that implies B is equal to C. And if A not equal to 0, BA is equal to CA, that implies B is equal to C. We say that cancellation law holding R. We say that cancellation law hold in R. Hold in R. Cancellation law hold in R. Cancellation laws in a ring. In a ring already we learned group theory. AB is equal to AC, A cancels, B is equal to C. This is the left cancellation law. BA is equal to CA implies B is equal to C. This is the right cancellation law. Left cancellation law, right cancellation. This is the left and right cancellation laws. Next. Theorem. Theorem. A ring R has no zero divisors. A ring R has no zero divisors. A ring R has no zero divisors if and only if cancellation laws hold in R. If and only if cancellation laws hold in R. That means a ring R has no zero divisors if and only if cancellation laws hold in R. This is if and only if means two parts, implies part and implied part. First implies part. Implies part R has no zero divisors. We can prove that cancellation laws hold in R. Implied part cancellation laws hold in R. We prove that R has no zero divisors. Let R has no zero divisors. Let R has no zero divisors. This is the implies part. We prove that cancellation laws holds in R. Cancellation laws hold in R. That implies A comma B comma C belongs to R. A not equal to 0. A not equal to 0. Assumption. AB is equal to AC. AB is equal to cancellation loss hold in R. Cancellation loss in ring is AB is equal to 0. That is to prove that B is equal to C. This is the left cancellation law. Next, BA is equal to CA. That implies B is equal to C. This is the right cancellation. Take AB is equal to AC. That implies AB minus AC is equal to 0. Common A B minus C is equal to 0. Let R has no zero divisors. That means A not equal to 0, B not equal to 0. That means A not equal to 0, B not equal to 0, AB not equal to 0. This is the first one. Whereas AB is equal to 0, that implies A is equal to 0 or B is equal to 0. It implies AB is equal to 0, A is equal to 0 or B is equal to 0. This place B A B minus C. This is AB. So A not equal to 0 since A not equal to 0. Either A is equal to 0 or B is equal to 0. So A not equal to 0, B minus C is equal to 0. That implies B is equal to C. Since take AB is equal to AC, we prove that B is equal to C. Similarly, we can prove that. BA is equal to CA. That implies B is equal to C. This is the implied part. Next, implies part. Let the cancellation laws hold in R. The cancellation laws hold in R. We can prove that R has no zero divisors. R has no zero divisors. R has no zero divisors. Suppose A not equal to 0, B not equal to 0, that implies AB not equal to 0. A not equal to 0 and B not equal to 0, that implies AB is not equal to 0. If possible, suppose that there exists, if possible, suppose there exists A comma B belongs to R. A comma B belongs to R. A not equal to 0, B not equal to 0. That implies AB is equal to 0. Definition of 0 divisors. Definition of 0 divisors. A not equal to 0 and B not equal to 0. That implies AB is equal to 0. That means AB is equal to 0. Take AB is equal to 0. AB is equal to 0. That implies A into B is equal to, already we can prove that some basic properties of ring. 0 into A is equal to A into 0 is equal to 0. 0 into A is equal to A into 0 is equal to 0. So A into B is equal to, we can written as A into 0. That implies B is equal to 0. This is cancellation of whole, cancel A. So B is equal to 0. B is equal to 0. It is contradiction. So our assumption is wrong. It is contradiction to B not equal to 0. It is contradiction. This is contradiction. This is contradiction. And A not equal to 0, B not equal to 0 belongs to R, and AB is equal to 0 is not true. And AB is equal to 0. This is contradiction. This is contradiction. A not equal to 0 and B not equal to 0. That implies AB is equal to 0 is not true in R. That implies AB is equal to 0 that is not true in R. Therefore, R has no 0 divisors. Therefore, R has no 0 divisors. This is the theorem. Again, I will explain the theorem. A ring R has no 0 divisors if and only if cancellation laws hold in R. If and only if means implies part and two parts. Implies part 1 and part 2. That implies first part. That R has no 0 divisors. We can prove that cancellation law hold in R. Next part, cancellation law hold in R, we prove that R has no 0 divisors. First part, let R has no 0 divisors. That implies we prove that cancellation law hold in R. That implies A comma B comma C belongs to R, A not equal to 0. AB is equal to AC. AB is equal to AC. That implies AB minus AC is equal to 0. That implies A into B minus C is equal to 0. A not equal to 0. Definition of 0 divisors. A not equal AB is equal to 0. That implies A is equal to 0 or P is equal to 0. AB is equal to 0, A is equal to 0 or B is equal to 0. That means B minus C is equal to 0. Since A not equal to 0, B minus C is equal to 0, that implies B is equal to C. Similarly, we can do that BA is equal to CA, B is equal to C. This is the left cancellation law and right cancellation law. Therefore, cancellation law hold in R. Next, implied part. Let the cancellation law hold in R. Since we can prove that R has no 0 divisor. That means AB is equal to 0, A is equal to 0 or B is equal to 0. Or A not equal to 0, B not equal to 0, that implies AB not equal to 0. If possible, suppose that there exists A comma B belongs to R, A comma B belongs to R, A not equal to 0, B not equal to 0, implies AB is equal to 0, the definition of 0 divisors. So, possible, AB is equal to 0, take AB is equal to 0, that can be written as AB is equal to 0. Already we have 0 into A into 0, some basic properties of a ring. 0 into A or A into 0 is 0. So 0 can be written as A into 0. A cancelled by left cancellation law. So B is equal to 0. This is contradiction. So B not equal to 0. This is contradiction. A not equal to 0 and B not equal to 0. That implies AB is equal to 0. Is not true in R. Therefore, R has no 0 divisors. This is the theorem. I will continue the next class. Okay. Thank you.